So for this given problem, we are asked to find the area of the trapezoid following with the given points. So these are our points. So we will first have a sketch of this one. So here. So in order to illustrate this one, so we have the first trapezoid. So this is our trapezoid. So for our area 1, this will be our area 1. So our coordinates will be 0, 0. This will be A and H, B and H, C and O. So A, this will be our A, then its height, A and height, then B and height, then the E3 will be C and O. So we will get the point slope of this one and for this one later on. So we will now get its area by first getting all the integral of the three areas. The area 1, A2, A3. So we will use this following equation. Then we remembered that for the formula of the point slope, so this is our point slope general form. So we have y minus 1 is equals to m times x minus x1. So to get the point slopes, so we will get the point slopes of a1 and a3. So for point slope a1, we will get the m slope. So m is equals to n minus 1 over a minus o, and then we will now get substitute it with this one. So 1 minus y1 equals m times x minus x1. So y minus y1, so our y1 will be 0, and then equals, so h, we will now substitute m to this equation. So h equals to a over a, rather h over a. Then for x minus x1, our x1 will be this one, x minus 0. So for our point slope a, this will be our equation for our form, y equals to h over ax. For the point slope a3, we have this one, a3. So we will now use the formula again for this one. M is equals to h minus o over b minus c. So using the general form, we have y minus 0, so is equals to the substitute m here. So it will be h over b minus c, then x minus c. So c right here. So h minus c. So for our point slope, we have this one, a3. So this will be our point slope form for a3. Next, we will now go to the following integrals. So from right here, so we will now use it right here. So dA is equals to the upper limit and the lower limit of this one will be the A and O. So for A1, we will now use the A1 right here. So h over a x dx plus the integral of with the upper limit b and a. So since it we only have the h and dx right here, so since this is the h only, so plus the integral, so we have b and c, so h over b minus c. Then this one, we will use the point slope of a3 into here. So we have this one. So we will now get out the constants right here to remain with these following equations here. So for this one, we will have right here h and then hc, separate it, and then we will now get the integrals. So for here, so we have h over 2a. So since a and o are our upper and lower limits, so we will get the integral of this one. It will be x squared over 2. So for the 2, we will now move it here in its denominator, plus h, then the upper limit b minus a, so dx will become x, so x, substitute it with the upper limit b minus a, so we will have this one. And for this one, we will have h over 2 quantity b minus c right here. So since we all know the integral of x is x squared over 2, so we will have this one. So minus hc over b minus c, the derivative of this one would be x, and then the integral cb with its upper limits. And now we will now solve for h. So we have a squared h over 2a. So we remember that we will just substitute x with the following integrals, and it all applies here. So multiply, and then we have this one, substitute x with its upper and lower limits, and x with its upper and lower limits. And then we will now cancel, since this is a squared and a, so we will now crush it, and this will remain with a later on. So a h over 2 plus this and this one. So we will just solve for this one. So cancel, and this one will be h quantity c minus b over 2. So we will have this one right here. So hc minus hb over 2, then hc. So we will have this one. And then we will now get the denominators of each. So we have 2. So we have the common 2. And then we will now use the LCD. We will, since we have 2 as our common denominator, so we will combine it all. So we will use 1/2 h. So since we have h as our common factors here, then b minus a plus c. Then we remembered earlier that our c will become the b2. C will become the b2, and then b minus a will be the b1. So right here, so let's just substitute it with right here. Then we can write it simply with this one. So b1 plus b2 over 2h. So we have now proven the area of the trapezoid.